So when we talk about the derivative, what is a derivative? And it is an application that you're going to put on the original function, and it's going to give you the instantaneous rate of change at any point. That's the same thing as saying the slope of the tangent line. There are different ways to write it. Two of them are like this. And like this when they ask for it. So that's going to be your two ways when you see. Sometimes you'll just see that people write, and they won't even write the of x. And there's some rules that we're going to go through. I'm going to do this quickly. The power rule. And this is the easy trick rule that they showed you all these different ways using limits. And now we got an easy way. And it says by definition, it's all this. But what it just says essentially is that if you have any kind of term brought to a certain power, oops, this needs to be, you move the power as a coefficient in front of the x, which is what we did here, and then whatever that power is, you minus 1. So some quick examples. If I have, let's say, what's the derivative of x to the third? So what I would do here is I would take this power and I would put it in front, and then whatever that power is, I would minus 1. So it's 3 minus 1, that gives me 2. Let's see. I got some other examples. I can make one up. Let's just say 4x squared. What I would do here is I would use this rule that goes along with it. It's called the constant rule. And what you would do, it's actually called the constant multiple rule. And what you would do is, so the constant multiple rule by definition looks like this. It's almost exactly like this, but it's going to say the derivative of a constant times, or of a term with a constant, we'll call it C, is going to equal, you're going to multiply this number times the constant. So it'll be n times C, and then you're going to do the same thing. You're going to minus 1. So in this case, I'm going to multiply this number. And all you got to do is memorize what to do. Don't try and understand, just this is what you do for these tricks. And they're all rules, lots of rules. And then I would minus 1, and that would give me to the first power. And then that would be my answer here. From here, we move on to using this, what we know, to what's called the sum and difference rules of derivatives. And these rules just say that if I have a bunch of terms and I'm taking the derivative of them, whatever they are, I can take the derivative of this one and then continue on, take the derivative of this one and then continue on, take the derivative of this one and continue on. Those are the sum and differences. So I'm just putting them all together. So let's take another example. What's a good color? Go with that. Okay, so let's say I have really can just make one up, but let's say I have a function x to the fourth minus 5x to the third plus 4x squared minus 6x plus 7. The sum and difference rule says that I can take the derivative of this one, this one, this one, and so on, and then just apply whatever operation is in front of it. So here, the first one, I would use the power rule. So I would bring 4, and actually I'm going to say, we'll write D, let's just write it f prime of x so you get used to that notation. That means the derivative, and it's going to be 4x to the third, because you minus the 1 here, minus, then I'm going to use the constant multiple rule, so I'll just multiply this times this, minus 1, and that gives me to the second power, plus, because this plus, 8x to the first. You really don't need to write x to the first, but, and then this is like 1 times 6, so that's going to give me 6. Okay, and then this is 1 minus 1. So that ends up being over here. I'm just going to think about something. I have x to the 1 minus 1. That's really x to the 0, and anything to the 0 power is 1. So that ends up being 6 for this 6 times 1, which just gives me 6. And then there's one more rule that I probably should have said before, but it's the derivative of a constant is just equal to 0. So whatever a constant, if you just have a number with no variables, the derivative of it is just going to be 0. So this right here is just a constant. So it's plus 0. So I wouldn't even write anything. I mean, I'll write it, but then. So that's your answer. You could rewrite it without the 0 and without this 1. So. All right, so the power rule is pretty straightforward, and you're going to base a lot of what you're doing from here on in science, if you get into physics and the rest of calculus, on that rule, that power rule. And you're actually going to do it in reverse in the next unit to do what's called the integral. But with this power rule comes new, you're not just going to get an easy problem with just a bunch of terms in it. So the next thing I want to go over is the product rule. I don't like that. Let me erase that. Okay. And the product rule says if you have two factors, I'm going to call this the first factor. So you're going to have something in parentheses times, let's say, another factor. Okay? You're going to take the derivative of the first. Well, actually, you'll leave the first alone. It doesn't matter what order you do it, but most of the time they say you leave the first alone. This is going to be your answer. If I was going to take the derivative of this, I'll leave the first alone. And take the derivative of the second times that by the derivative of the second. And then I'm going to add, now I'll take the derivative of the first because I left it alone before. I'm just going to write enough because I'm running out of room here. And I'm going to leave the second alone. So that's the product rule. Let's try an example. Let's say I give you f of x is equal to, here's going to be my first factor, 3x to the fourth plus 2x minus 1. That's my first factor, times x to the fifth. Here's my second factor, minus 2x squared and that's going to give me, now how you do this, how you're going to do this is you're going to take the derivative of it by, let's move this over, I want to have room. Leave the first alone. This is the rule. This is called the product rule. Leave the first alone. So I'm going to leave this alone. So I'll just rewrite. 3x to the fourth minus 2x minus 1. Then take the derivative of this one. And now we're going to use all our rules that we just learned. The power rule, where you're just going to put, all right, that's 5x, 5 minus 1. That gives me 4. Minus, use your constant multiple rule, and you have 4x squared. 2 minus 1 is 1. I can write it. You really don't have to. Then I'm going to add, and I always forget to do this part, this adding part. So make sure you remember. Now you're going to leave the second one alone. But you're going to multiply but you're going to take the derivative of the first. So you're going to have, it doesn't matter if you take the derivative of the first, leave the second alone, or take the second, it does matter when you're minusing. So just watch out. So then now you're going to have 3 times 4 is 12x, 4 minus 1 is to the third, minus 1 times 2 gives me 2. X to the 0 is 1. 1 times 2 is just 2. And the derivative of 1, if that's a constant, that means it's just going to be 0. That should be plus 2. I'm sorry. And then most of the time, teachers will let you leave it right here. But sometimes you'll get a teacher that'll want you to go ahead and FOIL everything out and do it that way. Also, to be honest, and I'm just teaching you this rule, but to be honest, you could just, let me rewrite these in here. You could have just, this is a 5 and a 2. You could have just FOILed this out, and you go this times this, and you could have FOILed it all out, and then used the sum and difference rules, like they turned into terms, and you would take the derivative of each term. But we're just trying to learn the different rules, and that's why I'm showing you how to do the product rule here. Let's see if I can think of another example to make. I think I have them written down. And this should have been a minus if you're writing this down. All right, so let's do one more example. And I'm not going to go over the quotient rule right now, but I will go over it the next time. What I might do, if I have time, is do one more sum and difference rule, but with some fractions. Yeah, I think that's what I'm going to do. I'm going to go over another sum and difference rule with fractions. So we'll go back to the sum and difference rule just because I wanted to show you. It's not always so easy, but it's still doable. Back to sum and difference rule. All right, so let's go back to this real fast and let's just say you have, we'll just say some function g of x is equal to -1/2 x to the 6th plus 2x to the 3rd minus 3x. What that would give you here is you would have this constant, but now you would have to multiply. Now you're going to take what in here, you're going to take just this derivative. So that's going to be 6x to the 5th plus, then you go ahead and get 2 times 3x squared minus 3, and then that x to the 0 is just 1. And then you would, -1/2 of 6 is -3. And then you have 6. I'm just simplifying it now. And then that would be your answer. You might want to use it for how to find a derivative, though, for something even more difficult. Like, what if I said, what is the derivative with respect to x of the square root of x? So what you would do there is go back to algebra and you would write, oops, sorry, I'm ahead of myself. You would rewrite this as x to the 1/2. And then you would go, okay, so the derivative, I'm still here. So then that means that would be -1/2